All right, on this next one, it says that point A has these coordinates, point B has those coordinates. How long is segment AB? To find out how long a segment is in the coordinate plane, we're going to have to use the distance formula, which says D equals square root of our change in x squared plus our change in y squared. Alrighty, so that's the formula I'm going to use. I'm going to start by marking this thing up and labeling this as x1, y1, and this will be x2, y2. Alrighty, and then I can just drop that into my distance formula. So the distance, the length of AB is going to be x2 minus x1, so 6 minus 2 squared, plus y2 minus y1, 17 minus 5 squared. Alright, then we're going to run through the order of operations, which says do the parentheses first. So I'll do the 6 minus 2 and I'll get 4. And it'll be squared eventually. And 17 minus 5, which is 12, which will be squared eventually. Alrighty, so I have the square root of 4 squared plus 12 squared. So the next thing in the order of operations after doing parentheses is do your exponents. So 4 squared is 16 and 12 squared is 144. There's no multiplication or division, so we move to addition and subtraction. And I see 16 plus 144 makes 160, all inside that big square root. So unfortunately, that's not an answer choice. So I'll have to simplify this radical, which means I'll have to break it down. The factors of 160 could be, say, 10 and 16. Factors of 10 could be 2 and 5. Factors of 16 could be 4 and 4. And 4 and 4 could be 2 and 2 and another 2 and 2. So I've broken it down to the prime factors. So the square root of 160 is like saying the square root of, I see it, 1, 2, 3, 4, 5 2's multiplied. 1, 2, 3, 4, 5 2's multiplied by 5. So if I multiplied all of that, it would give me 160 again. So we know whenever we try to simplify a radical, we look for doubles inside the radical. There's a double of a pair of 2's, so that's going to move outside the radical. Then there's another pair of 2's, so that will also move outside the radical. And then these guys don't have doubles, so they'll stay inside the radical. So I have a 2 times 2 on the outside and a 2 times 5 on the inside. We'll simplify that to be 4 times 10, square root of 10. So D is the best answer choice. On 6, we're trying to list the undefined terms. It's the very first thing we learned in geometry. Point, line, and plane can be remembered by PLP. So point, line, and plane. So 1, 4, and 5. So C is the best answer choice. On number 7, it says, Marcy made this statement: if 2 lines are parallel, then they have the same slope. Well, Marcy's pretty smart because that's correct. We know that parallel lines have the same slope. So Marcy's statement is true. We also know that perpendicular lines have opposite reciprocal slope. In case we need that for later. This one says, find the contrapositive. If Jack plays baseball, then Jack participates in sports. So we know that the beginning part of this sentence, after the if, is what we call our hypothesis. And the end of this sentence, after the then, is what we call our conclusion. And I know that conditional statements are written if P, then Q. So the hypothesis is usually labeled with a P, not an H. And the conclusion is usually labeled with a Q, not a C. So that's our normal conditional statement. This is asking for the contrapositive. Contrapositive does two things to the statement. It flips the Q and the P, and it also makes them the opposite. So it'll say squiggly Q and squiggly P, or if not Q, then not P. So this statement is going to be all kinds of backwards. We're going to flip the Q and the P, and we're going to make them negative. So we'll start with Jack participates in sports, but we're going to change it to the opposite. So we're going to say Jack does not participate in sports. So if Jack does not participate. All right, now we're going to use the opposite of what we had as the hypothesis. So if Jack does not participate in sports, then he does not play baseball. So not only did I flip the statement around, but I also negated it using the words not. So if Jack does not participate in sports is what I'm looking for. If Jack does not participate in sports, that looks good. Then Jack does not play baseball. I think that's the best answer. It's very similar to my answer. Alrighty, number 9. Raymond threw a ball, bounced at this angle. What is the value of x? Well, hopefully you know that these two angles add up to 90 degrees. You see the box down here. You know they're going to be complementary. So I'm going to set up a little equation where those two angles add up to 90. So it's going to say 2x plus 4 plus the other angle, 3x plus 6, equals 90. We'll combine our like terms. A 2x and a 3x make 5x's, and a 4 and a 6 make 10. And we can solve by getting all the x's on one side. Well, they already are, and then all the numbers on the other. So it's minus 10. So 5x equals 80, and divide. X equals 16. On number 10, they give us a pair of parallel lines. That's what that symbol means. AB is parallel to CD. So two parallel lines, and then they ask about these angles. So you need to look at those angles and be like, dude, those are alternate interior. And when I have alternate interior angles on parallel lines, I know that they're congruent. And that means that they're equal to each other. So 10x minus 30 is going to be equal to 5x plus 5. A little bit of algebra. I need all my x's on one side. So 5x minus 30 equals 5. Need all my numbers on the other side, so add 30. And x is going to equal 7. But I'm not looking for x, so don't pick A. I'm looking for the measure of angle ABC. So I've got to take that 7 and plug it back in. 10 times 7 minus 30. 70 minus 30 equals 40. So this is supposed to be a 40-degree angle. And the question asked me to find angle ABC, so this angle right here. So if this is 40 degrees, then what's this guy? Oops. It's this guy. I know they make a linear pair, so they add up to 180. So if that angle that we found earlier was 40, I can find ABC by subtracting from 180. So it looks like C is the best choice, even though it's not drawn to scale, and it looks like an acute angle.